This is Quantermain. It's a quad quantiser in the Ornament and Crime firmware. But it can do so much more than just quantize notes. It can be a generator of random modulation values. And with some creative patching, you can even turn it into its own generative music maker. I'll cover all of this and more in today's video. So let's get started. Now let's do a quick review of the user interface. There are 4 quantisers in Quantermain, A, B, C, and D, and you access them using the left knob. You just turn it and you can select the quantiser. As you're selecting the quantiser, the selection bar remains on the same parameter each time, so you can compare quantisers and change the same setting very easily. Use the right knob to turn and then select the parameter you want to change, press it, and then turn it again to select the options from the menu. As you change certain parameters, you will see the menu may change. For example, we changed here the quantization to semitones, and then an active notes menu appears. Turn it back off, and that disappears. So there are some hidden menus in the Quantermain menu system that become opened up once you select a certain value. A couple of key things to look at here. First of all, the quantisers are broken down by column by default. So there's a trigger in on the top line. There's a CV value to quantize. That's the unquantized value goes in there. And then there's the output down the bottom. And the output is what you send to your oscillator. Quantization can take place on a trigger, in other words, to a clock, or it can be continuous. You can select the clock source, and you can also select continuous mode. So anytime the input voltage changes, it re-quantizes very, very quickly. All of the quantisers can share the same trigger, or you can have different triggers for each quantiser, or you can break them up whichever way you want. You can also divide down the clock. So this means that quantization happens on a certain number of clock divisions. This is very handy if you want to have the same CV source going to multiple oscillators, but at different rates. So for example, for every clock tick, you'll send a new note to a lead oscillator. Every 4 clock ticks, you would send a note to a different oscillator, maybe a chord or a bass line to change. So that's a very useful feature for building musical progressions. You can delay the trigger of the quantization. In other words, if it takes a few microseconds for your incoming CV source to settle down, you can delay that using the trigger here. And of course, you can pitch up or down the final quantized notes by octaves, semitones, or a very fine-tuning amount as well if you needed to fine-tune it. Now let's connect up the output of Pam's new workout. I have an LFO here on output 4, which is just a sine wave that'll just cycle along. I'm going to attenuate it slightly because the output range is quite high. From 0 to 5 volts would be just crazy noisy. So we're going to attenuate it via the attenuator here in Mix Switch. Take the output of that into quantiser A, CV1 input. Now if we look at the CV controls for quantiser A, we can see that it's expecting a CV source on CV1, but it also wants a trigger on trigger 1. So let's patch clock from our mult here into trigger 1. And I'll patch the output of that into the volt per octave on oscillator 1, and we will patch oscillator 1 into the channel 1. The nice thing about the twin waves is it has a built-in VCA. So we can actually just gate that with this envelope over here that I'm going to be firing off using a gate that I've just taken off that mult. So whenever the gate fires an envelope's here, it'll trigger the VCA inside twin waves and we should hear a sound. Let's just go up and turn off quantization right now. So the notes are going to come in unquantized, so you're just going to hear the raw voltage coming out of this LFO. Now when I hit play, you'll just hear the oscillator not quantized making an awful racket because we're hearing the unquantized LFO. Doesn't sound very nice. Let's go in now to quantiser A, and we're going to set that first of all to just semitone. That will correspond to the 12 semitones on a piano keyboard. I'll just turn on all the notes in the scale mask so everything will go through. And as you can see, we're just going to quantize it to a semitone scale now. Sounds a little bit better. Sounds like you're just playing randomly on a piano. Now I can go in and play around with the active note scale mask. So I'm going to remove some of the notes from the scale mask so that we only have 3 notes on it, so it'll be a chord coming through. Let's take a listen. See, if I rotate the scale mask by turning the right knob here, watch, listen to the sound. It plays a different set of notes. It's almost like a chord progression is happening. So this gives us our first clue of how to use a quantizer for melodic development. If we can put this scale mask rotation under some sort of CV control, we are going to get a much more playable sound because we'll be able to change this over time and make it a much more interesting melodic progression. Let's go ahead and also use quantiser B. Now I'm going to have quantiser B send its note information to oscillator 2 on the twin waves. Oscillator 2 doesn't have a VCA on the twin waves built into it, so I'm just going to take the output of it, patch it into this Bafako ABC here, which will act as a kind of a poor man's VCA. It'll be gated with the same gate from the Pam's new workout here, an envelope. We'll go in here and we'll trigger the sound to go through, and I'm going to patch the output of this into channel 2 on the mixer. Now, I'm going to go and do something a little different on quantiser B. It's still going to be set to the same minor key, and we still have an active scale mask with only 3 notes in it. But I'm going to set the CV source to CV1. So quantiser B is also going to be sampling this input here, the same as quantiser A. But notice what happens when I change that from CV source 2 to 1. We get a new little submenu appearing called CV aux. This lets us do things like CV mapping parameters in the quantizers. Now, there are not a lot of them you can map, root note, octave, transpose, and so on, but the one that's interesting is to map the scale mask rotation. Now, a control voltage on CV2 input will rotate that scale mask for us. So like where I was turning the knob previously, we can now put it under CV control. And to do that, I'm going to patch the output of my push sequential switch here, which is a manual switch that I can cycle through 4 different CV values, into CV2, which will then rotate the scale mask for it. The other thing I have done is I have set the clock divider to 4 clock ticks. This means that quantiser B will only quantize a new note every 4 clock ticks. So quantiser A is going to be playing a melody like the arpeggio we were hearing earlier. Quantiser B will follow, but it'll be 4 ticks late. In other words, it's going to form a kind of a counterpoint to what you're hearing out of quantiser A. Now, the easiest way to hear this is to just separate out the 2 channels and just isolate them so we can hear what's happening. So here's quantiser A, like we had in the previous example. And you can hear that arpeggio just like we had previously. Now let's take a listen to what's happening with quantiser B. I'm going to turn up the volume. Do you hear every 4 clock ticks it's quantizing something different? Now watch what happens in quantiser B to the scale mask when I press the new CV voltage here on the push. It rotates. After 4 clock ticks, it picks up the new value. And you hear how the tone has changed? Now we can combine the 2 together with a little bit of reverb and shimmer. And of course, I can manually change the scale mask on quantiser A. Now let's add a second LFO into quantiser B and use that as the source of the notes to quantize. So I've got a second LFO, a slower sine wave on output 3 here. I'm just going to patch this into the B attenuator on the mix switch, and I've set the A attenuator into negative mode, so I can pitch down now with this as well. I can subtract from the voltage. I'll patch the output B even into the CV2 input on quantiser B. Now that means we have lost on quantiser B. We have lost the ability to do scale mask rotation, because now we're using CV2 as the input. So now we have a scenario where we have two quantisers with two different voltage sources, but sharing the same trigger clock. So they'll quantize to the same beat. So same setup, we've got the output of oscillator 2 going through a VCA that I've made out of the Pafaco ABC here into channel 2. Channel 1 is still oscillator 1, and this is a slower LFO here on output 3. I'm going to turn up oscillator 1. And now oscillator 2, which is the second LFO coming through quantiser B. Same setup, 4 triggers on quantiser B. Add a little reverb shimmer. And now I can pitch that up by just adding a voltage to it here in my mixer. That's where the mix switch is so handy. I can attenuate on one, add with another, invert, use this as a sequential switch. I'm going to do a whole video on this one. Love it. So straight away you're hearing that we have something very different going on here. Two counter-playing melodies, but still very much in tune with each other. And of course we can rotate our scale masks manually. Oh, that's nice. I like that. So two different CV sources, two very different moving sounds coming out of it, but all triggered off the same trigger clock. Let's look at using a sequencer like the Mimetic Digitalis. The Mimetic Digitalis is a 4-channel, 16-step grid sequencer, and a grid sequencer means it doesn't just move linearly through notes, it actually can cycle between different rows of notes, and the rows are organized in groups of 4. So we're going to use sequencer 1 here for oscillator 1 through quantiser A, and sequencer 2 through oscillator 2 through quantiser B. So let's get patching. Now, same setup, sequencer A is triggered using trigger 1, CV1 is the input, and it will play every note that comes through. Sequencer B, as before, again, same setup, scale mask, CV2 is the input, same trigger clock, and it's going to trigger every 4 divisions of the clock, so same idea as previous example. The fun starts, of course, when we rotate the scale mask. And you can jump to random positions with the sequencer, which resets the relationship between what notes get played and the clock ticks we're on. Quite nice. So here now you see we're taking a unquantized source of notes in the form of the Mimetic Digitalis, and we are quantizing it, and quantizing it like the previous examples. Now we've lost the ability to rotate the scale because we're using CV1 and CV2 input for quantiser A and B. We can still achieve a lot by actually just manually going in and changing that, and of course jumping around inside the sequence here. Now there are other modes of generating quantized voltages in the Quantermain app, and there are 3 we're going to look at now. Use internal sources of generated values, and those are the linear feedback shift register, the integer sequences, byte beats, and the logistic equations. So there's actually 4 of them. If we go into quantiser A, you notice now that I've changed from CV1, 2, 3, or 4 to the CV source LFSR, linear feedback shift register. And when I shift to this, you see a whole new series of menu options appear. Quite a lot of them, actually. Now, these are explained in more detail in the manual, but basically the idea here is you have a circular buffer, which is processing information, and as the bits come off the end of the buffer, they generate note values. It's a great way for creating generative music. As long as you get everything roughly in the same scale with the same range of notes, it'll sound pretty good together. So what I've gone ahead and done is I've turned quantisers A and B to be linear feedback shift registers. And I'm also going to use quantiser C here with plates. And I'm going to feed the output into the volts per octave. I'm going to patch an envelope here into the level input for triggering that. And now I can also set quantiser C to be a linear feedback shift register, and it's going to be connected, as I've said before, to plates. And so now we can mix in a third oscillator, which will be plates, and I'll take both outputs from plates here into channels 3 and 4 in my mixer. Let's take a listen. So again, we've got 3 different sources of generative notes being created. They're all being quantized. Oops. And sometimes it gets stuck. You might need to nudge it. I often find this can get stuck on a little note somewhere. You have to go in, change one of the parameters yourself. So there you heard a great example of making generative music using basically one clock trigger, and if you want some CV modulation, but you basically turn Quantermain into a generative source of notes, you patch it into a few oscillators and basically let that thing run and see where it takes you. Now let's look at using quantisers as a form of sample and hold and random modulation. Now obviously a quantiser is just a form of sample and hold that adds a little bit of magic in terms of quantization. So it takes a voltage or a generator source and turns it into pitch information. But at its heart, a quantiser is just a sample and hold module, and so we can use it as a source of modulation in our patches. In this example, I've swapped out plates for ripples and disting, which I'm going to use for some drums, and I'm going to use ripples obviously as a filter. And we're going to explore how we can use the quantisers with the generator modes turned on in Quantermain to modulate the filter for that lovely squelchy filter effect. So we'll start out with a fairly straightforward patch as before. Sequencer A is just going to be sequencing the first oscillator here in twin waves. It's going to take CV source from sequencer 1 here in the Mimetic Digitalis. It's triggered by trigger 1 as before, and it's just pitched down by 1 octave. So nothing too crazy going on there. So now if we just play this with the filter opened up. Let's look at how we can use the quantisers as a sample and hold source for modulating the filter and get some movement in that filter. I'm going to go over here to quantiser D, and we're going to use quantiser D for this. I found that the best source of kind of random values to use are the integer sequences. An integer sequence is just a form of generating numbers using sequences that are common in mathematics. For example, the first integer sequence we can use is pi, which is literally the digits of pi, the infinite non-repeating transcendental number that we all know from trigonometry. There's many more encoded in here, but we'll start off with pi. What we're going to do is we're going to connect the output of this into the frequency modulation source, CV source on the filter. And of course, this quantiser needs to be triggered, or this generator needs to be triggered. So I have trigger 4 here set up, and I'm going to send in a pretty fast trigger from output 5 over here on Pamela's new workout. So 4 times the clock speed. So for every note that's being played, there'll be like 4 ticks of modulation. So you'll hear that little bit of movement. Now let's take a listen. As you heard, the filter was being modulated, so you heard a bit of movement, but not an awful lot of movement. Now let's look at what's going on and why that movement isn't as big as we think it is. In the integer sequencers and all of the generators in Quantermain, there are 2 important parameters that you need to keep an eye on. One is the modulus and the other is the range. If the modulus is 24, that means it will only output numbers in the range of 0 to 23. There won't be anything over 24. You can, of course, increase it. So if I increase it to 28, the output will be in the range of 0 to 27. But there's another number that comes into play here, and this is the range. What that does is it takes the output range of the modulus and compresses it down even further to simply be in the range of 12 semitones. So here we've got this set to 12. So even though the modulus would give us an output value of 0 to 23, that is being reduced to between 0 and 11. Let's increase this up to 36 and see what happens. And let's take a listen to the impact that has on the modulation. As you can hear, the modulation is more pronounced because the voltages that are being generated here at the output now have a broader range to travel over, and so we're getting more of a modulation effect on the filter here. But if we set the integer sequence direction to swing mode, the movement of the sequence will go back and forth. So it'll go to the end and replay the other direction, and it'll basically pendulum back and forth. Let's take a listen. So there you heard a slightly different kind of tone and rhythm to the modulation, because after all now the integer sequence is moving back and forth across the generated numbers, and so when it gets to the end it pendulums back to the beginning. Now let's look at some self-patching techniques to feed the output of the quantisers back into each other and see what we can do with that. Remember earlier we talked about using a CV input to change the scale map rotation. Well, what if we actually used a quantiser for that? In this case, remember the melody is coming from quantiser 1. So if I want to rotate its scale map, I'm going to have to set its CV source to CV2. That opens up my CV aux menu here so I can adjust the scale mask. I'm going to set quantiser C as a linear feedback shift register mode. It's going to be in semitones, so all of the values are generated. And I'm going to have it clocked using the same trigger here, trigger 1, as quantiser A. But the clock divisions are going to be 8 ticks. So it will generate a new value every 8 ticks. Let's patch the output of quantiser C into the CV1 input, which is now, remember, on quantiser A, mapped up to CV1, is mapped to mask rotation, scale mask rotation. Let's take a listen and watch closely as the scale mask rotates every time you see a new trigger come in on quantiser C here on the screen, and you'll hear the notes change. There, did you hear it change? And you saw the note rotation happen? And there it happened again. And there it rotated, and there it rotated again. And again, our modulus and range is impacting the values being generated. So let's change the modulus and range to increase the number of notes being generated. The range of the notes, I should say, being generated, so we get a higher range of values on the output, and so we'll see more movement on the scale mask. So now you see by changing that range and modulus value on quantiser C, we're seeing more movement here. So that's one example of some self-patching, where you can take the output of one quantiser and feed it back into another quantiser's input. Now, if we can quantize voltages into voltage ranges, we can also quantize them to basically an on and off range, in other words, a trigger. Let's look at using a quantiser as a trigger source so that we can trigger other events in this patch. Now, we have one spare quantiser left here, quantiser B, and what I'm going to do with quantiser B is go into it and set it to semitone mode. And I'm just going to adjust the active scale map to have one note only, so it'll only quantize to one note. Now for the CV source, I'm going to choose the logistic equation generator. This is a generator built into Ornament and Crime Quantermain app. It's rather complex. You can look up the mathematics behind it on Wikipedia. I'm going to set the clock division to 4 clock ticks, so it'll take 4 ticks for it to generate a new value. And I've just pitched it up to the second octave so that it moves into the output range of closer to 5 volts. Because what we're going to do is we're going to patch the output of quantiser B here into the Y trigger input on the Mimetic Digitalis. So as currently set up, it's getting a trigger on the X input, so it's moving across each row. If it receives a trigger on the Y input, it'll move down to the next row in the sequence. So now what we have is a random source of gates going into, or triggers going into that Y input, and will change the sequence being played. And as before, we have our two generators modulating the patch. So we've quantiser D modulating the filter frequency, and we've quantiser C modulating the scale rotation for the melody. So now when I hit play, watch what happens to the little playhead position. It'll go up and down the rows as well as moving left to right. And you see there it jumped down and it jumped down again. That's because it's receiving a trigger on this Y input created by the generator here, the logistic equation, which we're playing on quantiser B. And if we look over here, we're still rotating the scale mask. You see there it changed. So a lot of movement taking place, probably a bit too much movement even, but all generated of one trigger, one sequencer, and using quantisers, we're able to create a lot more dynamic movement in the patch. I hope you found today's video useful and you picked up some tips and tricks for using quantisers. We covered a lot, so feel free to jump around and watch some sections again. As always, leave me some comments or questions in the comment section down below. And if you liked the video, don't forget to hit thumbs up. We'll put everything together for a final outro jam here so you can hear it all come together. Thanks for watching.